Well, we spend 11 or 12 trillion dollars a year on all energy. That's across all energy sectors. And to transition, we need about $62 trillion worldwide. And so
And there's a little over $1 trillion a year, according to Bloomberg, in all of these renewable, clean, green technologies,
right now,
including electric vehicles.
Yeah, but if you look at what everybody pays, so it's not only investment, but what people pay for all the energy, it's on the order of 11 or 12 trillion. So if that was moved, first of all, to not investing in any more fossil fuels or nuclear or bioenergy or anything else, or fossil vehicles, or we're talking about all energy, we could actually generate the capital we need to do this, to actually transition. But the savings are so enormous. I mean, think about it, because in 2050, the cost will be about $17 to $18 trillion per year. But if we electrify all energy, our energy requirements go down about 56% because of the efficiency of heat pumps, efficiency of electric vehicles, efficiency of electric industry, eliminating all the energy needed to mine, transport, and refine fossil fuels and uranium. It's about 11% to 12% of all energy. And end-use energy efficiency, we can get down 56% of energy requirements, plus the cost per unit energy is about 15% lower for clean renewables than like wind and solar compared to fossils. So,
and that big reduction is because, like, driving a car, the total energy of the fuel, only a small fraction of that gets used in the engine to actually move the car forward, 20% or something like that.
Yeah, only about 20% of the energy in gasoline goes to move the car.
But with electric, there's an extremely high efficiency of use of the primary energy.
Yeah, the electricity going into your car, about in the order of 80% goes towards moving your car, and the rest is waste heat.
Yeah, so there's a factor multiple of efficiency gain throughout the system if everything electrifies, even including transmission losses.
Yeah, there's a huge reduction of energy demand and going to electric vehicles. Same thing with heat pumps. Heat pumps use 1/4 the energy as natural gas heaters, so because they just move heat rather than create heat.
Yeah.
So those are the two main things, and then there's some in industry. There's some electrification improvements, and then getting rid of mining. That's about 11% to 12% of all energy worldwide.
It's for mining.
And so we calculate 56% reduction of demand just by going to electricity, and wind, water, solar providing the electricity. And then so that means that even if the cost per unit energy is the same, you're using 56% less energy, so your annual costs are 56% lower. But in fact, the cost per unit energy is going to be less. It already is less with the wind, water, solar.
Yeah.
We calculate about 15% less, so that's about a 63%.
Almost no marginal cost to run to it.
Yeah, there's no fuel cost at all.
It's deflationary. It's why it's the primary principal component of the Inflation Reduction Act, is because these things are fundamentally deflationary.
Right. But so if we spend $17.5 to $18 trillion per year on energy in 2050, and you go to wind, water, solar, we're ending up spending $7 trillion per year. So that's about $11 trillion per year savings. So if our capital cost is $62 trillion and we're saving $11 trillion a year, that's a payback time of 5 to 6 years, just in the energy. Health cost savings are another $30 trillion a year. Climate cost, another $30 trillion a year. So the social cost payback time is less than 1 year. So if we transition our energy system to 100% wind, water, solar across all energy sectors, when you account for health and climate cost benefits in addition to energy cost benefits, the payback time is 1 year, so if we galvanize society to actually do this, there's little downside to doing as fast as possible.
Yeah, the air will be cleaner. The effects, the ravages of climate change will be substantially mitigated. The risk for future generations, it's economic. I mean, in almost every instance where wind and solar goes on the ground today, it's the lowest cost option, even without subsidies, even though subsidies are important. And subsidies are used in every form of energy is maybe another thing to just touch on for a second, because people like to rail against the subsidies that renewables need or the subsidies that electric vehicles need, but it's the case that every single form of energy has been subsidized throughout our global system from creation until still.
Yeah, that's true. All energy has been subsidized.
It's foundational to national progress. It's food systems are subsidized as well because it's foundational. So it's
right.
Well, This has been fascinating. I really appreciate your time here and jumping into your story. I find it fascinating. I find it inspiring. You've been a hero to me and to many in terms of the impact that you've had. Your research, you've truly made a big impact in the world of climate and clean energy. And I've been observing it from afar since graduating from here, but it's just nice to reconnect. It's nice to chat about some of this with you in person. You know, some of it's probably pretty difficult too. I mean, the stuff we were talking about with the National Academy of Sciences were probably very personally taxing for you, which I can't even really imagine.
Yeah.
But I appreciate you opening up about all of that. And I guess I'll leave it with just one more question, which is, are you hopeful for the future?
Yeah. No, I've always been hopeful and still am hopeful because I know we can solve these problems.